So let's start with question number 1 in week 1, Introduction to Atomic Structure. Calculate the number of moles in 25 grams of calcium carbonate. I have the molar mass and required to find, as the question will ask me to find the number of moles, and the easiest way to find the number of moles is to divide the mass by the molar mass. Is the mass given? Yes. Mass is given, it is equal to 25 grams. And the molar mass has to be found for calcium carbonate by the addition of all the atomic masses of the different atoms. So calcium, the atom is 40.08 and carbon is 12.00 and oxygen is 25 multiplied by 3. Let me do the calculations here. So I will say that 25 multiplied by 16 multiplied by 3, 16 multiplied by 3, that's for the oxygen. 16 multiplied by 3, that's for the oxygen, and carbon is 12.01 and 40.08 is the calcium. So the total is 100.09. 100.09. Now we can calculate the number of moles. Number of moles is equal to 25 divided by 100.09 equal to 0.250 moles. Let's look at the significant figures. I have 3 significant figures here. I have here 4, here 4, and here 4. So I will choose the smallest one, which is 3. That's why it's 0.250 moles of calcium carbonate in 25 grams of calcium carbonate. In the second question for this week, how many atoms are present in 5 grams of aluminum? Atomic mass is 26.98 and Avogadro's number is 6.022 multiplied by 10 to the power of 23. In order to find the number of atoms, we first need to convert the mass to moles. So that's the only way that I can find the number of atoms is to find first the number of moles or number of molecules. So since this is only aluminum metal, so it's number of atoms. And to find the number of atoms, find the number of moles first. How to find the number of moles? Number of moles is equal to the mass divided by the molar mass. Again, same like last question. So 5 grams of aluminum divide the molar mass of aluminum, which is 26.98. That's equal to 0.1853 moles. Now we can transfer these moles into atoms by multiplying the number of moles multiplied by the Avogadro's number. So I will multiply this by Avogadro's number. That's equivalent to 6.022 multiplied 10 to the power of 23. And this is 0.1853. That's equal to 1.116 times 10 to the power of 23 atoms. Question number 3, calculate the mass in grams of 3.50 molecules of water. Now I need to do the opposite. In order to find the mass, I need to find the number of moles. I don't have the number of moles, but I have the number of molecules. So first, calculate the number of moles of water from each number of molecules. Number of moles is equal to the number of molecules divided by the Avogadro's number this time. So this time, number of molecules divided by Avogadro's number. So I will divide 3.50 times 10 to the power of 22 by 6.022 times 10 to the power of 23 and find the number of moles. That's equal to 0.05811 mole. If you have the number of moles, it's very easy to find the mass because mass is equal to the number of moles multiplied by the molar mass. That's equal to molar mass of water will be addition of oxygen and 2 hydrogens. So 2 16 and 1 two hydrogens, which is 1.008 multiplied by 2, in addition to 16, the total is 18.016. 18.016 grams per mole. Calculate the mass of water. It was equal to 1.047. We multiplied the number of moles by the molar mass. We got 1.047 grams of water. We need how many significant figures here? And since the significant figures, the smallest is 3 numbers, so I need 1.05 grams, only 3 significant figures.